So in this lesson, we're going to look at acceleration. So when we talk about accelerating, you might think about something like kind of speeding up, but acceleration also relates to slowing down. So we talked about speed in the last lesson. So in this lesson, we're going to look at what we mean by acceleration. So acceleration is the change in speed per unit of time. Okay, so another way to think about speed is velocity. So it's basically, so instead of having a constant speed, you have a change in speed. So for example, the last time we looked at this, so this here indicates that the speed doesn't change over time. So it's just a constant, as time goes by, the speed stays the same. So at any of these time points, if you were to measure the speed of the train, it's traveling at the same speed. However, with acceleration, what happens is you get this change in speed or change in what's called velocity. So there's a formula that you use to calculate acceleration. So acceleration is equal to final velocity minus initial velocity divided by the time taken. So it's the difference between the final velocity from the initial velocity, so starting off, divided by the time it takes for that change to actually happen. So if we look at an example of that, if a train starts at rest and increases its speed to 250 meters per second in 5 seconds, calculate its acceleration. So what's happening? So it starts at rest. So it's starting from 0 meters per second. And then after 5 seconds, it's picked up speed of 250 meters per second. So what we want to talk about then is what was the rate of change over the 5 seconds, or what was the acceleration? So the answer is going to be final velocity, so this is the final velocity, minus the initial velocity, which the train started at rest, which is 0, divided by the time taken, which is 5. So the answer to that then is 5 meters per second minus 2. So notice the way with acceleration we have this minus 2. And this minus 2 is used to distinguish between speed, which is meters per second, versus acceleration, which is meters per second per second. Okay, and that's why we have this minus 2 here. So that distinguishes acceleration from speed. So let's look at another example and work through the calculation. So if we have a look at this question here, so have a read over the question and pause the video and just give the question a go, see if you can work out the answer to it. Okay, so the first thing we want to do when we're doing a question like this is we want to read the question. So what are the things that we're looking for in the question? So we need, first of all, this what's known as the final velocity. We need the initial velocity and we need the time taken. So when we read the train, so if a train starts at rest, so if it starts at rest, that means that's the initial velocity. Okay, so that's this one here, so initial velocity. So the initial velocity is going to be, if it starts at rest, it's 0 meters per second minus 1, okay, meters per second. So it's starting at rest and increases in speed to 350 meters per second. Okay, so that's the final velocity, which is this one here, in 5 seconds. Okay, so 5 seconds is the time taken. So it's this one here. Okay, so time, just write as TT, time taken. So we can see we have everything that we need in the question in order to substitute it into this formula and then work out the question. So let's do that, okay? So we want, so acceleration, it's going to be equal to the final velocity. So the final velocity is 350 meters per second. Minus the initial velocity, which is 0 meters per second, which is this one here, divided by the time taken, which is 5 seconds. So that's going to be equal to so divided by 5, which if we divide those by each other, so it's equal to 70. So this is equal to 70. And what's important as well with this is that you put in the correct units. So its acceleration is 70 meters per second minus 2. Okay, so that's what its acceleration is. So the acceleration is equal to 70 meters per second. So that is like how to calculate it. Now notice as well that this is positive. Okay, so as in it's a positive number. Okay, so it's a positive integer. So that indicates that it is speeding up. Okay, so it'll have like a kind of like a slope like this. Now what can happen is as well, it could be 0. Okay, so that means it's just at like a constant velocity, or it could be like this. It could be negative 70. Okay, so that means that it's slowing down. So it doesn't mean that it's going downhill, it just means that it's slowing down. So if it's positive, that means it's speeding up. If it's 0, that means it's not accelerating, it's just at a constant, it's at rest. Or it could be something like this, or it could, sorry, not necessarily that it's at rest, it could mean that it's just at constant velocity, or it could be like this. Okay, so it could be just negative 70, which indicates that it's decelerating. Okay, so it's actually slowing down every second. So 0 acceleration just means that it's not speeding up or slowing down. If it's positive, it means it's speeding up. If it's negative, it means that it's slowing down. Okay, so what's really important is that you know this formula and that you're able to read the question and you're able to put the parts substitute them into the formula and then solve for the acceleration. So this here then is a graph. Okay, so again, along the x-axis, which is the horizontal axis, it gives time in seconds. And then along the y-axis, which is the vertical axis, it gives velocity or speed in meters per second. So if we have a look at this, we can see that so the graph it represents the motion of a train. So motion means like the movement of a train. Okay, so between 0 and 4 seconds. So if we look, so between here and here, the train's speed is increasing. It's getting faster. Okay, so we can see that from here to here, so the value is increasing as you go along. So it has a positive increase, okay, or a positive slope. So that indicates that the train during that time period is accelerating. Then what happens is between, let's say, so between 5 and 7 seconds, okay, so between this period here, the train is traveling at a constant speed. So there's 0 acceleration going on here. So it's just traveling along at a constant speed of 8 meters per second for this time period here. And then between 7 and 10, so between 7 and 10, so at this point here, we have the train is starting to slow down. Okay, so it's starting to slow down. So if you were to calculate, for example, use the acceleration formula, you would find that this here would give you a negative value, this here would give you a positive value, and then this here would give you a 0 value. So here it's slowing down. So a common mistake made by students is to think that the last part of the graph represents a train going downhill. That's not the case. The downward slope means that the speed is decreasing. Okay, so that's what that means. So that is acceleration. Okay, so again, what's important in relation to acceleration is that you know this formula and that you know how to use it and that you're able to calculate the acceleration of an object. And then also as well, when you get your answer, you're able to say whether the object is speeding up, whether there's 0 acceleration, or whether it's slowing down. If it's a positive value, it means that the object is accelerating. If it's 0, it means that the object is just at constant velocity or constant speed, it's not changing. Or if it's a negative value, it means that the object is slowing down. So that is acceleration, and that's how you measure and how you calculate acceleration.